So it is easy to write in terms of about desensitization feedback. AF is equal to A by 1 plus beta A, or it is going to be A by capital D. So the gain is reduced. So when you divide a number by another number, for sure I can say that the gain will be reduced. And D can never be small because D is 1 plus something. So even if worst case this beta A is going to be 0, then AF and A will be same. Otherwise, D will be always more than 1. So when you divide, the value of AF will be always reducing. One approximation I do when A beta is very large. When A beta is very large, adding 1 to A beta is not going to make any significance. Assume the A beta value is 1 lakh. It is 1 lakh. So adding 1 to 1 lakh, it will just become 1 lakh 1. It is not going to be that significant, right? So I can write 1 plus A beta will be approximately equal to A beta only. So when this condition happens only under this case, when A beta is very much larger, when A beta value is very huge, in that case, your A beta plus 1 is approximately equal to A beta. I can cancel A here. So the gain with feedback is effectively dependent on beta. So AF is dependent only on beta if A beta is very much larger. So AF is equal to 1 by beta is the reciprocal of your feedback factor. Okay, this is an approximate formula for AF. This is the exact formula for AF. So the gain depends only on the feedback network. You see, that is the beauty. You have an amplifier, you have all the biasing resistors, you have mixing network, you have sampling network. But finally, you see the gain with feedback, AF depends only on beta. So it is not dependent on any other parameter of the circuit. So which I can say the gain is going to be stable. The gain is highly stabilized. The improvement in stability is very good. So if the feedback network contains only passive stable elements, the improvement in gain is very high. So the feedback network will usually contain a resistor or a capacitor or an inductor. All these are passive elements, and all these are stable elements also. So if your feedback network is going to contain only these type of elements, then the improvement in stability will be very high. So increase in stability shows that the gain is made insensitive to changes in transistor parameters. So what is the point in having a gain which is dependent on beta? So it is not dependent on transistor parameters. So even if H parameters of transistors are going to change, even if I'm going to replace the transistor with a new transistor, all these are not going to affect my performance, affect my gain. Okay, so first point, which is very important advantage of your negative feedback, is stabilization of gain. So we have seen that the variation in gain after feedback is very less when compared to the variation in gain without feedback. And also one important point, we have seen that the gain after feedback depends only on the feedback network, not on the amplifier. So amplifier bias resistors, if you change the power supply given to the amplifier, if you change the transistor H parameters, if you add a new transistor, whatever you do, the gain after feedback is going to be essentially independent of all these changes, and it is going to be completely stable. And how you can even more make your circuit stable, highly stable, means if you have your passive components inside the feedback network. Passive components means if you have RLC inside your feedback network, then the gain will be even more stable. So we don't prefer having L and C inside the feedback network because the phase change may happen. So we predominantly have only resistors inside the feedback network. In a resistor, voltage and current are in phase. So it will not add any additional phase shift to your signal, right? So when you say feedback network, predominantly we'll be using only resistors as feedback network, even though you have power loss caused by these resistors, but resistors are predominantly preferred because the current and voltage are in phase inside a resistor. So due to that reason only, we are going to use the resistors in the feedback elements. And the gain, whatever we are saying, the gain can be one among the four gain. So I told you we have four types of amplifiers: voltage amplifier, current amplifier, trans conductance amplifier, and trans resistance amplifier. So A means you don't think it is always voltage gain. No, A can be AV, voltage gain, GM, trans conductance, AI, current gain, RM, trans resistance. So it represents, it A represents one among the four values depending on the type of the amplifier, and AF can be without with feedback. So put suffix F to everything. AV will become AVF, voltage gain with feedback. GM will become GMF, trans conductance with feedback. AI will become AIF, current gain with feedback. RM will become RMF, trans resistance with feedback. Okay, so we use the term A everywhere, but A necessarily need not be voltage gain or current gain. Please be very clear. It depends on what amplifier you are considering. Okay, it strictly depends on what amplifier you are considering.